again, okay, untuk chapter group 14 elements. Okay, masih lagi chapter yang sama. Okay, kali ni part 4. Okay, in the previous video, part 3, we learn about the relative stability of oxidation state. Okay, so oxidation state untuk group 14, kita ada dua, positive 2 and positive 4. Okay, group 14 oxides. Okay, daripada positive 2 and positive 4 oxidation state, okay, kita boleh dapat two types of oxides. Okay, first we have monoxide, MO, with oxidation state positive 2. Example, CO, carbon monoxide, SiO, silicon monoxide, GeO, SNO, and PbO. Okay, another type of oxides is dioxides, MO2, with oxidation state positive 4. For example, carbon dioxide, silicon dioxide, GeO2, SNO2, and PbO2. Okay, so dekat sini dia tunjuk ini MO2. M represents the group 14 elements. Okay, so kita ada two types of oxide, monoxide and dioxide. Okay, first we look at monoxides. Okay, the thermal stability, okay, from carbon monoxide to tin oxide easily oxidized to a dioxide. Okay, PbO, stable. Okay, that is the boiling point. Okay, structure and bonding. For carbon monoxide and silicon monoxide, simple molecule with van der Waals forces. Okay, manakala yang lain ialah ionic structure with ionic bond. Okay, acid-base nature for CO and SiO is natural. GeO, SNO, and PbO is amphoteric. Amphoteric, tahu kan, dia boleh react dengan acid and alkali. First, we look at monoxide. Monoxide of carbon, silicon, germanium, and tin are easily oxidized to dioxide when heated. Okay, jadi ini dia punya chemical equation for carbon monoxide, silicon monoxide, germanium 2 oxide, tin 2 oxide. Okay, jadi ada 4 monoxide ini, dia senang untuk oxidize to dioxide. Okay, daripada carbon monoxide dia jadi carbon dioxide, silicon monoxide, silicon dioxide. Okay, cuma untuk silicon monoxide, dia punya chemical equation dia lain sikit lah berbanding carbon monoxide. Okay, GeO and SNO. Okay, because silicon monoxide only exists in the gas phase at temperature above 2000 degrees Celsius. So when cool, it disproportionates spontaneously to silicon dioxide and silicon. Okay. Okay, lead 2 oxide forms the red color compound triplumbum tetraoxide Pb3O or PbO2 to PbO. It decomposes back to PbO if the temperature exceeds 470 degrees Celsius. Okay, this is the chemical equation for lead 2 oxide. Okay, acid-base nature of the monoxide. Okay, dalam jadual yang awal tadi saya dah bagi acid-base nature of monoxide, di mana carbon monoxide and silicon monoxides are neutral. So carbon monoxide is quite reactive and combines readily with oxygen, sulfur and the halogens. Okay, ini chemical equation untuk carbon monoxide react with chlorine gas. Okay, the monoxide of germanium, tin and lead are amphoteric. So bila amphoteric, they can react with acid and base. Okay, they react with dilute acid to form salts. Okay, M here represent the germanium, tin or lead. Okay, here we have M2 plus. M2 plus is the salt and water. Okay, another one, they can react with dilute alkalis to form salt. Okay, here is the chemical equation. Okay, next we look at dioxides. Okay, dioxide we have carbon dioxide, silicon dioxide, germanium 4 oxide, tin 4 oxide and lead 4 oxide. So the thermal stability, okay, stable even at high temperature except for lead 4 oxide. Okay, here is the boiling point. Okay, decompose when heated. So very low boiling point for lead 4 oxide. Okay, structure and bonding for carbon dioxide simple molecule, silicon dioxide giant molecule, and the rest is a giant molecule ionic transition structure. Okay, their acid-base nature for carbon dioxide and silicon dioxide is acidic, and the rest are amphoteric. Okay, dioxides. Carbon dioxide is a linear molecule. The molecules are held together by weak van der Waals forces. Hence, it has low melting and boiling point. So, this is the structure of carbon dioxide gas. Okay, simple covalent molecule. Okay, the shape is linear. For silicon dioxide, has a giant infinite three-dimensional molecular structure. The melting point and boiling point are very high because the atoms are held together by strong covalent bonds. So here is the structure for silicon dioxide. Okay, you can see the giant covalent structure. All oxide of group 14 elements are thermally stable except for lead. Okay, jadi lead will decompose from lead 4 oxide to lead 2 oxide. Okay, this is the chemical equation for decomposition of lead 4 oxide. Okay, jadi semua dioxide semua dah stable, jadi dia tak perlu untuk decompose melainkan lead 4 oxide. Okay, PbO2 dia kena decompose kepada PbO. Okay, means PbO is more stable than PbO2. Okay, next acid-base nature of the dioxide. Okay, kalau yang tadi neutral dengan amphoteric, yang ini dia adalah acidic and amphoteric. So, carbon dioxide and silicon dioxide are acidic. Okay, carbon dioxide react with dilute sodium hydroxide to form the carbonate. Okay. Okay, manakala silicon dioxide dissolve in hot and concentrated sodium hydroxide to form silicate. Okay. So, acid-base nature of the dioxides. Okay, germanium 4 oxide, tin 4 oxide and lead 4 oxide are amphoteric. Okay, amphoteric maksudnya dia boleh react dengan alkalis and acid. Okay, both lah. Okay, with dilute acid, okay, here is the example using tin 4 oxide. Okay, here is the chemical equation for reaction with dilute acid. Okay, another one with dilute alkalis. Okay, using tin 4 oxide, here we have the chemical equation. Okay. Example. Okay, carbon and lead form oxides when burned in air. Write an equation for each reaction. Okay, kedua-dua carbon and lead, okay, membentuk oxide when burned in air. Okay, carbon produce carbon dioxide. Okay, for lead produce lead 2 oxide. Okay, kenapa dia punya produk tak sama? Okay, satu carbon CO2, satu lagi PbO. Explain why the reaction of these elements are different even though both elements are in the same group. Okay, so the answer is the most stable oxidation state for carbon and lead are +4 and +2 respectively. Although lead is group 14 elements and has 4 valence electrons, the 2 s electrons are not used for bonding due to their inner electron pair effect. Okay. Okay, finish part 4 group 14 elements. Okay, the group 14 oxide, monoxide and dioxide of group 14 elements. Okay, thank you. Okay, see you in part 5.